Tesla's gigantic Gigafactory 1 in Sparks, Nevada has been able to churn out battery packs for the company's groundbreaking line of electric vehicles at the rate of around 5,000 a week for some considerable time now. In terms of sheer volume, that puts Elon Musk's operation in a stronger position than all other rival electric car companies put together. This is an important factor in the company's soaring share price, and by extension, Musk's world-beating bank balance. So how on earth are they accomplishing it? And how much quicker can Elon Musk's groundbreaking firm potentially go? Today, we're donning our hard hats for a look behind the scenes at exactly how Tesla builds batteries so fast. Elon Musk has made no secret of the fact that one of the main stumbling blocks he faces on his way to weaning humanity off the internal combustion engine is the quality and capacity of the batteries his cars use. Making a car run on electricity is easy enough, apparently. But storing enough precious juice on board to make owning an electric car a comparable or even superior proposition than regular gas guzzlers has thus far proven elusive. And while other aspects of technology, most notably microchips and integrated circuits, have become exponentially more powerful and compact over time, battery tech has lagged behind, in both technical sophistication and the sheer ability to deliver and manufacture units at scale fast. One way Elon Musk and Tesla have managed to ramp up battery production is by bringing battery manufacture under the same roof as his other automotive activities. For now, and over the next few years at least, Tesla works in partnership with Japanese electronics firm Panasonic, an old hand in the battery business. But rather than sending away to have batteries manufactured at a Panasonic plant, Elon Musk cleverly insisted Panasonic bring its production lines to the Tesla Gigafactory. This obviously has the benefit of nigh on eliminating stubborn shipping delays, but also, thanks to Musk's not inconsiderable resources, gives the battery design process space to breathe, in quite literally the largest building on planet Earth. Vast apparatus like the cathode press or cathode rollers fit comfortably in the mammoth facility, with plenty of scope to scale up, for instance, the cell aging process. Cell aging, since you ask, is an essential part of the battery cell manufacturing process. When a cell first rolls off the production line, it's entirely useless from a chemical standpoint, until that is a protective layer called the SEI, solid electrolyte interface, is allowed to form around the electrodes. This can take 10 to 12 days, although innovations at the Gigafactory have enabled Panasonic engineers to age cells in place as part of a whole battery and not individually, which is far more efficient and therefore quicker. It's worth emphasizing at this stage that for Elon Musk, factories aren't simply warehouses that happen to be crammed full of whirring machinery. How they operate and function is, in his view, every bit as important as the finished car itself. He said as much to a shareholder meeting 5 years ago. We realized that the true problem, where the greatest potential lies, Musk began, is building the machine that makes the machine. In other words, building the factory. I'm really thinking of the factory as being like a product. Therefore, almost no detail is left to chance. The Gigafactory itself, for instance, wasn't just plonked down at random on a conveniently flat bit of desert. Instead, the entire vast 15 million square feet plant lies on a rigorously precise north-south axis. Partly, this is in order to get the best out of the rooftop solar arrays, but also it helps streamline the sophisticated indoor navigation systems for the factory's small army of robots. Those robots perform a majority of the car and battery-related manufacturing tasks in the factory. Just as an example, when components need moving from inventory to the production line, robots perform the function more quickly and more reliably than humans, using a combination of smart GPS and magnets embedded in the floor. This is also, fairly obviously, a boon from an industrial safety point of view. This isn't to say that every little detail of all that goes on in the Gigafactory is automated. Far from it. Indeed, reflecting Elon Musk's data-led approach, when a job is demonstrably tackled better by human beings, for instance connecting lengths of dangling pipe, a human being is duly hired. As Musk himself admitted not long ago, we did go too far on the automation front and automated some pretty silly things. Panasonic's expertise is of course a major factor in Tesla's success, for now at least. The electronics giant is said to have sunk some $1.6 billion into its work at the Gigafactory, not least committing to adding a 14th production line in the Gigafactory last year to meet demand. Indeed, the company is only now starting to make a meaningful return on its investment. Still, Panasonic knows as well as anybody that Elon Musk is not a man to tolerate less than exemplary performance. And as it happens, Elon has been extremely vocal about his wish to make his own batteries just as soon as it's commercially feasible to do so. And although back in June, Tesla and Panasonic renewed their commitment to work together until 2023, Elon Musk is openly hiring engineers to begin building batteries in-house at Fremont, California, and at the forthcoming Gigafactory in Berlin. Indeed, Musk issued a veiled threat to Panasonic on Twitter in 2019 by suggesting their work at Gigafactory has lagged. Tesla won't spend money on more capacity until existing lines get closer to 35 gigawatt-hours theoretical, he said, dubbing Panasonic's disappointing work rate as a constraint on the Model 3 and sending shockwaves through the battery world. Musk's willingness to hold Panasonic over a barrel commercially like this has at least enabled him to wring ever greater performance out of the Japanese firm. Through publicly expressing disquiet at the company's supply chain delays and making no secret of his wish to be rid of them, he's inspired Panasonic to develop new, more efficient and quicker techniques for delivering the latest generation of 2170 lithium-ion cells, currently being used in the Tesla Model Y. Denser, more efficient batteries like these, which largely supersede the older 18650 batteries Tesla previously used, is key to Tesla's vision of making electric cars even more efficient, quicker out of the factory, and crucially more affordable over the coming years. Elon Musk's very public, very ambitious claims, like his promise to deliver a $25,000 ticket price Tesla in the next couple of years, certainly serves to keep Panasonic's wits sharp and their production methods lean. As ever a man with his eye on the horizon, Elon Musk also looks forward to an era when rare, ethically problematic materials like lithium, and especially cobalt, can be eliminated from Tesla's manufacturing processes altogether. And in a September announcement, he brashly claimed Tesla is looking to produce 100 gigawatt-hours worth of battery cells reliably by 2022. That's enough for 1.4 million vehicles with or without help from Panasonic. So there you have it. Tesla builds batteries so fast by housing as much of the process as possible under one smart roof and replacing fallible human hands with robotics, but only where appropriate. That and aggressive tactics with commercial partners, plus outrageously ambitious public targets that Elon Musk's deservedly massive ego demands he meets. Also, the coffee at Gigafactory is said to be insanely strong. Does Elon Musk drive his commercial partners and employees too hard in the ruthless pursuit of excellence? Let us know in the comments, and don't forget to hit subscribe for more supercharged tech content.